Hello, I'm Shaumik, and I'll be presenting our work, Unsupervised Learning for Abdominal MRI Segmentation using 3D Attention WNet. I have no financial interest to declare. Biomedical image segmentation can help radiologists in decision-making by helping them focus on the region of interest. But manual segmentation is a very time-consuming task. Many automatic segmentation techniques have been proposed in recent times, but most of them are using supervised learning, where manual labeling is needed to train the algorithm, which is again a time-consuming task. We try to overcome this need of manual labeling by using unsupervised learning for volumetric MRI segmentation. UNet is one of the most common network architectures used for supervised segmentation. Gidegier et al. Proposed a WNet architecture which employs two cascading units for unsupervised segmentation of 2D regular day RGB images, where the first unit is expected to generate the segmentation, which is then forwarded to the second unit, and the second unit is expected to reconstruct the original input image back. Soft encast loss is calculated on the output of the first unit, and reconstruction loss is calculated on the output of the second. We have used this architecture as our base model. Okta et al. Proposed an upgrade of the UNet architecture by using an attention gate which can help the network to suppress the regions that are not relevant. We created a 3D version of the previously proposed WNet architecture and incorporated attention gates with the skip connections and created a 3D attention WNet for volumetric segmentation. During training phase, both of these attention units are used, but during inference, only the first one is needed, as that is the one predicting the segmentation. For training the algorithm, intensity normalization and calculation of the weight matrix was performed before supplying the images to the network. Then forward propagation was performed, followed by calculation of the loss and back propagation. Finally, conditional random field or CRF was applied as a post-processing step to recover the edges. As mentioned earlier, two different loss functions were used here. Soft encast loss was used on the output of the first attention unit, and we have used SSIM for the reconstruction loss, and it was calculated on the output of the second unit. For this proof of concept experiment, we have used T1 in-phase volumes from the Chaos Challenge dataset. 25 subjects were used for training and 10 were used for testing. Now let's have a quick look at the results. On the left are the inputs and on the right are the outputs obtained from this framework. At the center, the manual segmentation can be seen. Here only the cluster which was predicting the liver has been shown. It can be observed qualitatively that the model was able to segment fairly well without any manual labeling, though some over-segmentation can be observed. It can also be observed that small vessels which were not segmented out by the manual rater were segmented out correctly by the network. While analyzing the results quantitatively, the results yielded approximately 0.79 intersection over union and 0.88 variation of information, while being compared against the manual segmentation. So to conclude, we presented here a proof of concept for unsupervised 3D abdominal segmentation by using our proposed 3D attention WNet and have shown promising results. As future work, end-to-end training can be performed by incorporating the CRF into the training pipeline. Furthermore, pre-training of these two units separately on a small dataset with manual labeling in a supervised manner, and then continuing the training on a large dataset without any manual labeling in an unsupervised manner as proposed here, can help improve the performance of the model further. These are our references. And thank you so much for your attention. Feel free to contact me for any further information or your feedback. Thank you.